Now let's look at collecting data. Okay, now we know what the different types of data are. The collecting data, okay, for collecting data we have to define what data we want to collect. But before that, one of the few things that we need to keep in mind when collecting data is we want to make sure that we avoid any biases and ambiguities or errors in data collection. What data we collect must be a true representation of what the population from which we are collecting data represents. Okay, it should be a true representation. There should not be any errors or biases that creep into the data collection process. So results from flawed data will be suspect. And however sophisticated the statistical analysis you may use and however accurate your analysis may be, it will be like garbage in, garbage out. So what comes in, if it is flawed, then it doesn't matter how well you do the analysis, out comes bad results. So we need to make sure that these flaws and biases and ambiguities are kept out of data collection process. So for that, we need to make sure that there are no confusion in terms of what each variable means. An operational definition and a precise statement of each variable, what it means, must be developed. In the absence of correct definition, you're going to have errors in data collection. So for that, the first step is to establish a business objective. I talked about business objective earlier. So here are some examples of business objectives. So you have to have a set business objective, and in order to meet that business objective, what kind of data we need, and we define those data very precisely in terms of what we want to collect. And where is the data going to come from? So you can define data sources broadly into two categories: primary sources and secondary sources. Primary sources is where the data collector, the person who collects the data and the person who analyzes the data, are one and the same person. I collect the data, I analyze, then that is a primary source, and I have direct control over what gets collected and how it gets collected. The secondary sources are when you have a separation here. Somebody collects the data and you take the data and you analyze the data. So you don't have any control over how the data gets collected. You simply use the data from the other source. So some examples are census data or industry data that gets published in the internet, and you need to rely on the accuracy of, you need to make sure that the data that you get from secondary sources are reliable and trustworthy. Okay, so here are some sources of data that fall into 5 different categories. Okay, some are primary and some are secondary. So there is data distributed by an organization or an individual. So this will be like government organizations, industry groups, or individuals like Nate Silver comes up with the data he publishes. Yeah. Or data can be outcomes of a designed experiment. You design an experiment. We'll talk about designing experiments later when we talk about ANOVA. So you design an experiment and you collect data. So that will be a primary source, the outcomes of designed experiment. The responses from a survey. So you send out survey responses. So this is again a primary source. The results of conducting an observational study. So there is a difference between experimental study and observational study. We'll talk about that later on. An observational study will be one where a process is already ongoing and you simply observe the data. As opposed to experiment, it will be where you design a process, you run the process, and you collect the data. Okay. And data collected by ongoing business activities like checkout counters and online purchases. These are data that gets generated automatically through the process of your business. And this is the source of big data that we come across these days. Okay, so here are more explanation of what I just went over. Okay, designed experiments, survey, observational study, and so on. Okay. Now we also need to think of data in two terms. This is population and then sample. Sample is a smaller group taken from the population, and population is a group that is complete. So it includes all the individuals or items. So it is a complete group. Sample is a smaller group taken from the population. And the sampling procedure must be such that this sample represents the population correctly. Okay. So here is a visual representation of what I just said. So population, this is a complete list, and this is a partial list. It's selected few individuals. Okay. Why do we do that? Well, it's less time consuming to measure only few individuals, as opposed to if you want to collect data from the entire population, may be very costly and time consuming, cumbersome, and maybe impractical too. It's, maybe, if you talk about the population of the entire United States and you want to measure, census is a measurement of the entire population, and even that, it's not possible for them to record data from everybody. So they have to rely on some statistical techniques to project those individuals who are not captured by the census. So oftentimes measuring the entire population may be impossible too, let alone being time consuming, costly, and cumbersome. Okay. Now, is the data source of data structured or unstructured electronic data? How the electronic data is formatted? How is it coded? So structured data would be data that already has columns and rows fixed, and you have the data and you take it and analyze it. But unstructured data would be data that is in a haphazard format. For example, if you have a bunch of emails from executives and you want to see in how many emails there is a mention of a particular product. So now you have to go through each and every email and figure out the data. So the source data are the emails, but those emails are in a very unstructured format. So you have to take the unstructured data and then bring it into structured format before anything else can be done. Now we're going to assume structured data in all of the chapters that we're going to be covering in this course. Okay, so here are some examples of structured data and unstructured data. And when you collect data, oftentimes there may be some problems with the data. Not a lot of problems, but maybe some observations, there may be some errors. So there could be typographical errors, or there could be values that are recorded that is impossible or undefined. And there may be some values that may be missing. A particular individual, you say, oftentimes race of an individual, often people leave that blank. So you may have a unrecorded value, missing value. And there may be outliers. Outliers would be the most data are within a range, say salary. So salary could range anywhere from, I don't know, maybe 25, 30,000 to say 200, 300,000 is the range. Okay. And there is one or two data that's like 2 million or 10 million. So it falls way outside the normal range, so those are outliers. Now outliers could sometimes be a typographical error. Instead of typing 200,000, suppose you type one extra zero and it becomes 2 million. So such irregularities must be viewed, okay, and we must fix those irregularities. Now Excel, there are some features in Excel that can be used to figure out whether there are any problems in the data, but most statistical software packages automatically will they have tools to identify irregularities in the data, so we can then investigate and see what kind of remedial action must be taken. So cleaning up data is a very important step as well. And then sometimes we have to recode a variable into something else. For example, suppose we have college majors. Okay, and there are like 50 different college majors. So your data is a categorical data, and there are 50 different possible values. Now you want to take that and then recode it into College of Business, College of Engineering, College of Arts and Sciences, and so on. So you're going to take a particular column of data and then recode it into a different column that represents the original values in a different way. So recoding and redefining the categories. Now we can also, sometimes we may want to take a quantitative variable and then convert that into categories. For example, if you have salary and you want 20 to 30,000 in one category, 30 to 40,000 in as category number 2, 30 to 40,000 category number 3, and so on. So you can take a quantitative variable and then recode it into a categorical variable. So when we recode, we want to make sure that the codes, the recoded value covers everything in the originals. You can't leave anything out when you're recoding into a new variable. So recode variables sometimes may be necessary as we collect data, and that's part of data cleaning and data preparation.